morning, everyone. Welcome to the TriStar webinar. My name is Thiagu Palaniappan. Today, we'll be looking at the new Creo ANSYS simulation that was just introduced in Creo 7.02, right? One of the latest date codes of Creo. They had just released it. Again, just those who are not familiar with our company here, my name is Thiagu Palaniappan, and as for TriStar, we are a company that specializes in helping manufacturing companies adopt software systems and processes to allow and enable better and more efficient product development. And we do this by being the largest resellers worldwide, the value-added reseller for PTC products. We are headquartered in Phoenix, Arizona, and we do have our team spread across the United States and Canada. We do Windchill implementation. We offer custom solutions. We also help out with training on the various PTC products, whether it's going to be Creo Parametric, Creo Simulate, or the new ANSYS products, as well as the Windchill solutions. And we also have some custom solutions that we offer. Okay. So with that said, real quick on the agenda here, I wanted to just go do an overview first on the computer-aided engineering landscape in Creo. Many of you may be Creo users, some of you may be new, some of you may have used it for a long time. I thought it'll be good to take a look at a high-level overview of what are the different computer-aided engineering tools that we have inside of Creo Parametric, and also talk about the new Creo ANSYS Partnership that has been there for like the last 2.5 years or so, starting with Creo Simulation Live. PTC has started to integrate some of the ANSYS solutions into Creo Parametric, the latest one being Creo ANSYS Simulation that we will focus on in this webinar. Now, just a quick note on if you do have a handout section in the webinar, there's a handout section if you want to download that PDF that gives you some information about Creo Simulation Live and the new Creo ANSYS Simulation, just to gives you an idea. I would encourage you to download that. And if you have any questions, feel free to start typing in the questions area. As and when we get towards the end of the presentation, I'll try my best to answer those questions, but feel free to start typing in those questions. We'll also go through like a capability comparison as to how Creo ANSYS Simulation compares against, for example, the current Creo Simulate that you may be using, or even Creo Simulation Live that you may be using. We'll go through some examples and also answer your questions here. So many of you may know that PTC's powerful CAD system is Creo Parametric, and we also have a very powerful PLM system, which is Windchill, PDM Link, and there are several other additional products associated to that. However, on the CAE side, on the computer-aided engineering side, PTC does have a pretty good footprint, I would say, all the way from back in the 90s. This has been there, and they've continued to develop it. So many of you may be aware of Mechanica, or currently called Creo Simulate, that does structural, thermal, and vibration and fatigue analysis. On top of it, we do have for mechanism dynamics or kinematics, and also for, you can drive parameters instead of Creo using a MathCAD worksheet, do some 1D tolerance stack-up analysis, to do a statistical tolerance analysis. All those have been there for a while now, and for the last 2.5 years or so, PTC has started partnering with ANSYS, and the first product was Creo Simulation Live. And with Creo 7.02, which is technically the MO20 date code, they have this ANSYS simulation product. I want to focus on that in this webinar mainly. We'll also quickly take a look at Creo Simulation Live if you have not seen it before. So there are the reason to have these multiple different products is it allows you to scale depending on the role in your company, right? Some of you may be design engineers primarily focused on design, or product design engineers that may not be a full-time FEA analyst. Some of you may be somewhere in the middle, wherein you may have done some analysis, you have some analysis background with other softwares, or maybe even Creo Simulate. So you may be looking for like a quick and easy to use solution. At the same time, you want to have some high fidelity accuracy when you do your analysis, right? That's kind of the whole reason why PTC has partnered with ANSYS. They're all there are two solutions now that are ANSYS powered. We'll quickly go over that when I do the demonstration. We'll talk about it. There are also other, for CFD, they have Creo Flow Analysis, symmetrics-based product. There's also fluids inside of Creo Simulation Live. So there are different options available now. If you've not been following the simulation tools evolution inside of PTC products for the last couple of years, there has been some newer products that they have introduced, and we have been doing quite a few webinars on these. So feel free to check out at TriStar.com. We do have other webinars on specific products, but today we'll focus more on ANSYS simulation, specifically inside of Creo Parametric. Now, this ANSYS PTC partnership, the main goal is to allow the design engineer that's using Creo Parametric for their day-to-day activities in Creo. You're able to give them the power of ANSYS. We all know about ANSYS, right? They've been in business for more than 45 plus years now. And then PTC itself has been in business for about 30 years with their Creo Parametric and Windchill solutions and many other solutions that they've added recently, like Onshape and a few other SaaS-based products. So this partnership allowed PTC to integrate the ANSYS Discovery Live product, which was completely GPU-based, mainly meant for designers for a quick directional tool. But then if you're looking for more of a high fidelity, higher accurate solution, PTC is now integrated their ANSYS Mechanical solver. The solver itself is ANSYS Mechanical, but it's the old ANSYS AIM or the Discovery product that you may be aware of that is fully integrated into Creo Parametric. And it's continuing to evolve with different capabilities over the next couple of releases, starting Creo 8, 9, and so on. Right now, what I'm going to show you is Creo 7.0. So again, the 30 years of the CAD expertise from PTC versus, and the 45 plus years of simulation expertise from ANSYS, the golden standard in design and the golden standard in simulation, both coming together to create these two products, right? So they started off with this one, starting Creo 4.0, you had the ability to do some live simulation like structural, thermal, modal, and fluids. Starting 7.0, that was Creo Simulation Live. It's completely GPU based. You don't even get to see the mesh, right? It's meant to be used for a quick what if scenarios during the initial concept stage. And then starting Creo 7.0.2.0, they had added another product. So there are two products here that we're going to be talking about, Creo Simulation Live and Creo ANSYS Simulation right in here. This is more higher fidelity solution, still easy to use, but it uses a traditional CPU-based pre-processing. You get to do your mesh refinement, run the analysis, and then look at your reports. At the same time, you can go back and make changes and rerun it, etc. Right? So you got both more of an analyst focused type solution, still that a design engineer could use, as well as a much more quick feedback, instant feedback type solution, which is Creo Simulation Live, where during my initial concept design stages, I just like to get some direction if I'm going the right direction with my structural and thermal performance of the product that I'm designing, right? So those are two options you have now, and both are licensed, right? There was a trial license for Creo Simulation Live that you could try out, and for the ANSYS simulation, it has to be purchased, right? Or both of them are purchasable add-on licenses to your Creo Parametric. So again, Creo Simulation Live has been supported since Creo 4 MO90. Some of you may be in Creo 4, 5, 6, or 7, right? It has been there since Creo 4.0 MO90 date code. And the purpose of that first integration of ANSYS Discovery Live into Creo Parametric, the purpose of that is to give engineers instantaneous feedback as they work on their design. They're able to apply some boundary conditions and loads and quickly get feedback without even doing any type of mesh per se or doing typical pre-processing work that you're all used to doing in a typical traditional FEA solution. You will have to go and defeature the model. You'll have to spend some time doing the setup, right? In any CAD embedded tool or even in a CAD agnostic tool like an independent FEA tool, you're always spending that time. Creo Simulation Live is quite different because it's not leveraging your CPU, it's using your graphics card's GPU. It's GPU based, which means instantaneous. As soon as you apply it, it takes a few seconds and you're going to see the result in there. And is that going to be accurate? It might be within 10% of a higher fidelity solution, but it's more for a directional tool. So it's mainly meant for users that may not be experienced, and as well as for analysts. Maybe you can reduce some time up, later on in your higher fidelity solution by doing some quick upfront check, right? That's what is Creo Simulation Live is meant for. Now, starting Creo 7.0.20, they have this Creo ANSYS simulation, which allows you to still use the ANSYS, the power of ANSYS and its solvers. However, it's a lot more more accurate, since it uses the ANSYS mechanical solver, and you have better options. Maybe you can assign contact, interfaces. You could also apply some joins for specific behaviors. So this is for maybe some of you may have used some ANSYS products, or even some other FEA solutions, maybe where you need better control on the meshing. Maybe you want to refine the mesh, and much more of a CPU-based solution, right? That we are all used to saying, where you do the pre-processing. Anything you do before the run button is pre-processing. Once you run the analysis, and then you do the post-processing, you solve it and look at the results. So they're like, it's really kind of scalable, like two types of solutions here, depending on your requirements, depending on where you are in your design stage. Are you going to be doing final validation check, or would you rather be you're still in a concept stage where you're trying out things? You're probably in your R&D phase right there, where you're trying out things, and you don't want to be spending time sending it to the analyst and waiting for a couple of days to get back the results. Those are the two use cases here as to why there are two different products, and both are ANSYS powered, right? One is available starting Creo 4.0. The ANSYS simulation is available starting Creo 7.0.20. The latest date code is 7.0.30, but it's available in 7.0.20 and 7.0.30. Real quick, just to reiterate some of the advantages of Creo Simulation Live is the biggest advantage is the real-time feedback, right? It is using GPU technology, right? And so you don't even have to see the mesh, or not everything's happening behind the scenes in quick times. Since it leverages the GPU. So there is a graphics card requirement. If you go to ptc.com and look up for Creo Simulation Live, there's a hardware check utility that you could run in your computer, and it'll tell you if it's a supported graphics card or not, right? It has to be CUDA-based NVIDIA graphic cards, and there are information about supported graphics cards in the PTC support page in there. And so let's mainly focus on this new product that they've just released about a couple of months ago, right? End of last year, basically 7.0.20, where they released a couple of exciting extensions inside of Creo Parametric. One was the generative design extension that was more AI-based design, and then the other one was Creo ANSYS simulation, and we'll focus on that now. So like I said earlier, it allows you to do structural, thermal, and modal analysis. Maybe additional capabilities might get added in the future, but this is the start, right, of that. And it also has ANSYS solver and the mesh, right? You're able to see the mesh with the results. You can go and refine the mesh. If you are a very experienced, seasoned FEA user, you may know the different meshing refinement techniques. You can do that. Or you have, for newer users, we just have a simple slider that allows you to just go from a very fine mesh to a coarse mesh, etc. Right? There are different, just a single slider to make it easier for new users as well. You can also export your setup and everything that you've done inside of Creo ANSYS simulation into the ANSYS mechanical, right? Maybe you want to do some higher end analysis that may not be available inside of Creo ANSYS, and you could export that and do it in here too. So it's a new one in there. I'll show you some examples in a little bit here, just to go over some of the capabilities that we have on the structural side. Obviously, you have your fixed constraint, your displacement constraint, where you're able to control the XYZ, rotation translation. You have a special type of constraints like cylindrical constraint ball, frictionless, planar, etc. And also loads, right? The typical loads that you would expect in any FEA tool: force, pressure, moment, etc. Right? You can also apply a load at point and then kind of distribute it on a surface. Very useful during my industry days. I used to use it a lot when you simplify a large assembly wherein you really don't have to have the full load path. You know mathematically where the magnitude of the load and where it's applied, but you're more interested in certain other areas based on the load path. You can just say, I want to apply it on a remote point. It's kind of like the total loaded point that we have inside of Creo Simulate, very similar to that. It's very useful when you work on large assemblies again. Okay? And then as for thermal, some of you may be interested in checking the thermal performance of your PCB assembly, wherein you're obviously able to simulate conduction, convection, and radiation heat transfer, right? Inside of Creo ANSYS Simulate, and you are able to assign the convection heat transfer coefficient. If you want, you can do a CFD using our Creo flow analysis and then input that into Creo Simulate. That's kind of the traditional process we've been doing, but inside of here, you're able to just use some empirical values for the convection heat transfer coefficient, apply the heat load, and then the radiation as well, right? Surface-to-surface radiation is not yet supported, maybe in the future, but you can assign the emissivity value in there, right? So those are. And then what it allows you to calculate is the temperature distribution, the heat flux, etc. Right? And then meshing itself, we all know that when FEA itself, finite element analysis, is all about divide and conquer, right? All you're really doing is you're taking a structure, dividing it into tiny, manageable structures, what we call mesh and elements and nodes, as you all know. And then you're using your algorithm to solve for deflection, stresses, temperature, modal frequency, etc. Right? So those are that's the key basics of FEA. So in a H element code like ANSYS, the finer the mesh, more accurate is the solution. So we do have some options to control the mesh. There is a default mesh that itself is pretty good because ANSYS has this so-called physics-aware meshing. So depending on are you running a structural versus a modal versus thermal, it understands to apply a specific type of mesh, right? Whether it's going to be hexahedrons or tetrahedrons, it understands that based on the geometry also. But you can control that, right? If you have good experience in finite element analysis, you're able to go and manually adjust, like for example, based on curvature or based on proximity, or globally, I want to make everything really a fine mesh. You have some options. Or if you're a new user, relatively new user, you just have a simple slider to go from a fine mesh to a coarse mesh, etc. Right? So you have different options. It's all about speed and the time you're willing to spend in that pre-processing upfront, right? But all those capabilities are there, which we didn't have obviously in Creo Simulation Live, because that was purpose-built to get immediate instant feedback, whereas this one is now you're taking a deeper dive into your analysis model, and you're trying to integrate them. You're integrating them. You're essentially asking it for more information, more accurate information in specific areas, maybe just before the final validation. So you're able to make some engineering judgments from there, right? So that's the goal here. They also support idealizations, and I'm sure all of you understand what is idealizations. They are nothing but mathematical approximations in any analysis model, right? Do you have to have the entire CAD geometry when analyzing it? Not necessarily, right? I may have a driving belt, or I might have a bushing, and the driving belt's job in my assembly is to just impart stiffness. So why should I be doing the actual CAD geometry as a 3D idealization or a 3D mesh? I could just create a spring to mimic that particular driving belt, for example, right? So I may just use 1D or 3D spring elements inside of my assembly here. So you could see up in here, I'm just creating a spring right in there, right? And I can assign torsional or longitudinal stiffness. I could also, assume that there is a mass of my entire engine assembly that I may be analyzing. I could just, create a simplified rep or remove that entire large assembly, but then use a point instead, and on the center of gravity, apply a mass point, a simple mass element in there. And then I could have, analyze on the geometry that I may be interested in. So these are all idealizations. that will be very helpful if you may have sheet metal parts or thin geometries, wherein shell idealization becomes important. So right now it's surface shells mainly that is supported, but in the future, mid-surface shell compression may also be supported, right, in the future release. But it's nice to see that, that the first release of the ANSYS-powered Creo ANSYS Simulate does have pretty much a good set of initial capabilities that a seasoned FEA user might want to get a higher fidelity solution there. Connections are very important, as you know, when you work on large assemblies, or even when you have 2 or 3 parts in your assemblies and you want to know accurately capture the real world interaction between those, right? You want to have a specific degree of freedom between these components, right? So typically it's done using interfaces definition in most softwares. For some of you who may have used Creo Simulate, we could use rigid links, weighted links, some spring elements to create a specific behavior between multiple components. We also have obviously interface definition. So within ANSYS, there's going to be a contact definition. As soon as you bring in a large assembly or even a part with multiple bodies that we support in Creo 7 into ANSYS Simulate, it's going to automatically detect contacts for you. So when I say contact, right now it's bonded, right? But in the future, we may have, there would be some, additional, you can also do some sliding effects right now with contacts, but there might be some advanced contact options in the next few releases. You can also add joints between a body to body or ground, or multiple bodies, like in the steering joint assembly here, right? I may want to have a specific behavior between the 2 cylinders, right? It could be fixed, could be having a hinge connection joint or a translation joint, depending on what kind of degrees of freedom you want. Relatively speaking, between those 2 parts, you're able to mimic the real world behavior using these options, right? That's connections are also supported. So we don't want to think that it's only for parts, it's also for assemblies, right? Where you're able to control that behavior. And finally, the results, right? The results can leverage GPU. And so if you do have a good like NVIDIA CUDA-based graphics card, even though the solver itself is using the CPU, but the results could use GPU if it's there. It's not a requirement. It can leverage that. You're able to look at various plots, add additional probes. There is simple and basic and advanced type of results, right? I'll show you a little bit during the demo in the next half hour or so here. You can also look at the mesh with the results, right? Save the results. You're able to export everything as an XBR file, all your setup and everything, including your results, and then you can reuse it later on during a design review meeting, or maybe even create templates. As a company, you may want, you do some certain products, certain analysis very regularly, and I may want to just save out my templates as an XML file, and then so others in the company who may be new could reuse these templates for future use, right? Now, when they work on their analysis, all they do is just use a template, so it quickly gets these different results that I typically plot out when I'm running a structural or a thermal or a modal analysis. Okay, so just to kind of, before I do a demonstration of some of the capabilities that I talked about, if you look at PTC's Creo Simulation portfolio, what you're seeing is about 2.5 years ago, this is kind of where we were, right? We still have the Creo Simulate. PTC still has that Creo Advanced Simulate, right? Very good products. I myself have used it as tremendous, a lot during my industry days. It's still there. Both allows simple static analysis as well as nonlinear analysis, large deformation, vibration, what have you, right? Including thermal, transient, and steady state, etc. That's still continued to be maintained. But now with the ANSYS powered solutions, there's like a lot more in here. So you could see a few additional products being added the last couple of years. Some of them recently, right in here, like the Creo generative topology optimization, the Frustum-based AI, or a Creo ANSYS simulation. These 2 are the ANSYS products right in here. One starting Creo 4, the next starting Creo 7.0.2.0. So I personally been in the analysis world for some time here. I'm really excited about this partnership between PTC and ANSYS, and looking forward to see more and more of integration in the future releases starting Creo 8, 9 through 10. So from a capability comparison, some of you may be interested in, okay, how does this compare against your current tool? What you may be having Creo Simulation Live, or you may be having Creo Simulate Extension, or the Creo Advanced Simulate extension currently, and there's a quick snapshot in here, right? These are these are the two ANSYS driven or ANSYS powered products, I should say, right in here. And the one, these two right in here are the existing, formerly called Pro Mechanica, now called Creo Simulate, right? And as you can see, the biggest advantage of Creo Simulation Live is a real-time feedback you get, right? It works on parts assemblies, but you get real-time feedback, right? But if you want to do much more of a mechanical solver-based simulation where you need to have control on the meshing, you need to have also some control on the behavior of interfaces between components. That's when like joins, right? And you can see the H methodology of meshing. That is more Creo ANSYS simulation capabilities, right? So I'm sure this probably going to change in the next couple of releases where PTC is probably going to add a lot more to it. But this is the current state of all the capabilities in here. So with that said, let's take a quick look at I just want to run a video first just to kind of show you really quickly here a very high level overview before I do the demo of Creo ANSYS simulation. So it can work on parts and assemblies. This is actually part of a motorcycle bike frame assembly we use in our demo data sets these days. You may have seen, the new data sets from PTC. That's one of the data sets, and I have a simplified rep of just the frame assemblies, the critical components that I'm interested in. I'm able to use those joins that I mentioned here, and maybe even spring idealizations to kind of mimic that suspension in there, right? At the same time, I'm able to use the ANSYS solver, and it's just Creo Parametric right now. And instead of that, you go to ANSYS simulation, set up your materials, boundary conditions, etc. Look at the mesh, refine the mesh if you would like, apply these joints and contacts, and then pretty much run the analysis, and you're able to review the results here as we speak. I'm interested in a few components in here, not the entire assembly. Does it work on simple parts? Absolutely, but again, the purpose of this is a higher fidelity type solution compared to Creo Simulation Live. So both can work on parts and assemblies. It just depends on at what stage of your design you are in to determine which tool you should be using, right? That's pretty much it. So with that, let me just go and switch to Creo real quick here. Let me just open up Creo. I have that model already set up here. I'll also show some setup from scratch. But before I actually show that model, that model, is part of a larger assembly. I just opened up. You see the Creo view, and I'm loading the actual Royal Enfield Interceptor. They're one of the demo products that we have been using. I'm just going to open that in Creo view real quick. It's still loading the parts as we speak, and there are a couple of sub-assemblies in that large assembly that I'm interested to analyze, and we're going to see how I'm leveraging Creo ANSYS simulation to do some structural analysis on that motorcycle assembly, right? Sub-assembly there. So it's still loading this as we speak. It's a large assembly, and there it goes, right? So what you see right now is I have and both those, and many of you may know Creo View. If you already use Windchill, you probably do know that every time when you check in your files into Windchill, there is a lightweight viewable that gets created if you have set it up, and that's the viewable right now that I'm seeing here, right? In this case, I have a standalone Creo View that I've opened, and I've just opened it in my Creo View right there. This is where I may be able to do markups, exploded states. It's pretty straightforward. I'm just reviewing the design, so I've opened it, and there are a couple of assemblies in here that I may be interested in, and if you think about it, right, I do have. I don't want all these components there. Instead of that, I may want to just apply the load of the bike rider, or for example, right? That's what I want to mimic. So what I did was I did exclude quite a few of the components. It's a smaller subset of that larger assembly, as you can see here, right? And what I've done here is, if you see, I've applied there are some load sets right in here. There are 4 loads I've applied. So all you do is you go into Creo Parametric, go to Application Simulate. Applications ANSYS Simulation, and then all you do is you get to create different types of studies in here. You can add a new study, right, or import a study if it's already done. Maybe in Creo Simulate or Creo Simulation Live, it's able to bring in some of the properties inside. And then you can apply your setup itself, right? The type of Newton-Raphson method that you want, the solver settings, the convergence settings. That's gonna, and then you pretty much do your work your way from left to right. You do your constraints, your loads, right? Apply your material and run it, and maybe you can mesh it before you do that, right? You can generate the mesh, control the mesh settings, and view the results, and even add some probes in here, right? So in this case, I've already, as you can see, there's like different load sets I've applied in here, right? If I go redefine one of them in here, I'm just using my XYZ triad in here and just applying loads, and different unit systems are supported, as you can see here, right? Regardless of what unit system Creo Parametric is in, you're able to go and change that unit system during the application. Then there's the engine load. This is where I could use that, I could potentially select a point where the engine load, the engine itself, the CG of the engine is concentrated, but then I could say that's going to be distributed on these, right? I could use that option. So, this multiple load sets are already added in here. And then what about the contacts itself, right? So there's like, as soon as you bring in an assembly, the system picks up the contacts for you, and you can change it. We can also manually add them, of course. But if I go to the contact between these two components right now, right, if I go into any of those contacts, and if I go redefine that, as you can see, I have the option right now what is supported as bonded and no separation, right? Which pretty much no separation, meaning it allows a little bit of sliding, right? But later on, we might have to have nonlinear contacts are not yet supported. Maybe in the next future releases, it is probably in the roadmap. But that's the first step in here. So it has picked up the contacts. And I also applied some joints in here, right? So if I go to each one of these components right in here on the shock axis in here, I have a joint. If I go to each joint, the options you have is you can control, is it going to be fixed, it's going to be behaving as a hinge, translation, slot, cylindrical, etc., right? So different options available for you there. So it is, it is kind of ready for a large assembly is what my point is with this demonstration here. I've also added some spring elements in here, right? A couple of spring just to mimic that suspension, so the behavior there. So if I go into that spring and I have a different springs, let me go redefine these. And if I go into my spring behavior, as you can see, I could specify a longitudinal one or a torsional spring. Is it 1D or 3D? Depending on, do I need the stiffness in X, Y, Z, etc., right? And then, of course, the free length of the initial conditions there. So you're not really created any CAD geometry there, right? I just selected a point from this geometry and a point from this geometry and saying, okay, that's kind of how, when you saw me in that video where it was in the deflection plot as it was moving back and forth, this VR capturing that spring did play a role in there, right? So I got a couple of springs in here, a couple of springs in the rear for this side as well, right? And then there's your results. Results can be automatically done, meaning that there are ways to use templates, right? I can save this out as a template. I can rerun or update the results quickly if I want to have specific type of reports, but your basic von Mises stress deflection, all that is available, right? So if I go activate my results for this assembly right now, it's just going to plot out my von Mises stress of this assembly right in here. And I could look at in whatever system I'm comfortable in, right? So maybe I'm more of a metric guy looking at megapascal or maybe PSI, and depending on your unit system, you can always review that. You can also control the maximum, minimum, or show where it is maximum or minimum right in there. It's currently showing this is the place. Maybe I'm going to focus on that area and see how we could improve that. If it's having a good factor of safety, etc., right? The typical things that you would do when you work on an FEA solution, right? So that's really what we're doing here. And then there's your displacement. I could also create additional results. Once I create additional results, I'll have to just update the results. You can go, there are different types of contour plots, vector plots, or just use from template, right, options in there. So that's one. And now there is, I do see in here in this one, there is this particular subassembly here that I might be interested to analyze it in a little more detail, right? This is the overall assembly. What I'm going to do now is let me just I'm going to open up a subassembly now of that large assembly. So let me erase these from my RAM instead of Creo. And I'm going to open up a larger assembly, a smaller assembly, I should say, and we could analyze just to show where I have those contact and the bonding, and the contacts are going to be important, right? So that's just the ones that erases it. We'll go through that. In the meantime, let me take a quick look at while it's erasing those components. Let's see here. A quick look at the questions. Okay, there's a quick question here. Creo Essentials has this ANSYS analysis capabilities or a separate add-on? So yeah, it is a separate add-on. So it is not included in Creo Essentials. In Creo Essentials, what we have is Creo Simulate Elite or Elite functionality, which is kind of like a very basic version of our PTC's own Creo Simulate. But both Creo ANSYS Simulate and the Creo Simulation Live, they both have to be purchased. It is an add-on extension. It is not bundled inside of the Design Essentials or the new Creo Design Essentials. Let me see if there's any other questions, on that topic here. Let me just, while it's still erasing that component, let me go pull up a quick comparison chart that you might that I had pulled in earlier. If you look at my comparison chart in here, and so yeah, both these Creo Simulation Live and Creo ANSYS Simulation, right? Both of them are purchasable. They're not included in anything, right? So, but Creo Simulate Extension and Advanced Simulate Extension, I know, are bundled in some of our newer packaging, right? But that, yeah, not these two in there. So let me see if there's any other questions as we wait for it. Looks like that yeah, had quite a few components in there. Let me see if it's still erasing it. And one thing I didn't show yet was the Creo Simulation Live. We can take a look at that too once I'm getting rid of these components that I have in the RAM. It's more like I mentioned about directional tool versus a full-fledged higher end tool in there, right? There are two different kind of use cases here. So we're going to be showing you that too. Real quick, it's the only thing is it requires some GPU requirements, right? So when I say GPU requirements, if I open up, let's see here, while it's still doing it, I can quickly talk through that. So there is, if you go to PTC's website, ptc.com, and then go to this Creo hardware check, you will see a little hardware check for Creo Simulation Live, and depending on are you in Creo 4 or Creo 6 or 7, when you run that, it will let you know if there's if your graphics card supports that, right? So I do have an NVIDIA graphics card with 4 gig of video RAM. PTC recommends 8 gig of video RAM. I'm talking about the actual video RAM itself, right? The minimum requirement is a 4 gig video RAM. I'm talking about the video RAM. I'm not talking about the actual computer's RAM in here, right? And these are some of the supported ones that they recommend. I mean, you could always, the best is to run this utility and it'll let you know in there. So if I go into mine in here real quick, if I go to my NVIDIA panel, I'll show you that there's if I go into my NVIDIA control panel that I'm opening right now, and maybe just minimize all this in here. I'm just going to take out my, there it is, right? So let me just go to Task Manager here. And so you see that currently the CPU and the GPU, I have this M Quadro M2200. So when I use Creo Simulation Live, it's going to use GPU versus the CPU for Creo ANSYS Simulation, right? So that's the one. Okay, so I'm going to just take out that if I go to my details in here, let me just take out some of the processes in here, and then we'll just do something from scratch as well here. So let's go into here, and I'm going to go end the task. And I'm going to launch. So there's my Creo. So I had Creo view with that large assembly there, and we showed you one large assembly there. Let me just launch Creo 7030. That is the latest one. And here's my NVIDIA control panel here. If I go to my system information, it'll have the video RAM on it. And, as you can see here, got a dedicated video RAM, 4 gig in there. That's kind of what I'm running with. And with 8 gig, that's what PTC recommends in there. So your hardware check utility, that's really what it's going to be checking actually. So 7030 is currently the latest one. 7020 and 30 supports Creo ANSYS simulation actually. Once it launches, I'll show you a setup from scratch as to how we are able to control the mesh refinement and your typical FEA, a higher end FEA, but still it's quite easy to use even for new users, right? Some of you may be experienced in ANSYS or not, it doesn't matter. It's the key thing is you're getting the solver, right? The power of ANSYS inside of Creo. So I'm going to open a part here, unlike that large assembly, where let me open up, let's see here, one of the parts. Opened a much more a simpler design here compared to the large assembly that I had opened earlier. And we'll go through some of the options available, or some of the capabilities available inside of the ANSYS simulation. So it's done in Creo, or it could be an imported model, it doesn't matter, but let me just go shading with edges, and I go into applications, and just to make sure the different applications we have, this is Creo Simulate that used to be called Pro Mechanica, we still have that, and this is the ANSYS simulation product, and this is Creo Simulation Live. Both these, the live simulation and this, are ANSYS powered, right? So go into ANSYS simulation, and immediately it's giving me the 3 options here: structure, thermal, or model, right? So remember the physics aware meshing that we were talking about. I'm going to just select structure for now and hit next. And it's really looking for contact detection. So you might be wondering, why does it have to detect contact in a part? Now, PTC does support multi-bodies starting Creo 7. So in the same part, we could have multiple bodies, and we would like it to control or detect those contacts, right? That's what it's doing here. In case there are multiple bodies, it's going to be detecting that. And those things, probably could be hidden by some config options in the future, but just an FYI, right? It's really detecting those. And now I am from inside of Creo Parametric. I did not import, export any file to ANSYS and in a standalone application. I'm just working inside of Creo. See, I'm still in Creo Parametric, and there are my tools in here, right? So I'm able to assign a material, right? I can go to simulation material and assign materials, or maybe I can just do some, I have this, all of you are familiar with the mini toolbar in Creo. I'm able to just go fix or apply different displacement constraints in here. So I'm going to just go fix these surfaces real quick. So maybe we'll just control select and I fix it. Maybe I want to apply a load in here, right? That's probably what I might want to do. I may want to assign some load in here. Now, before I show you that, I could go to refine model, and you do have options for applying your idealizations, your connections, and your mesh control, right? So pretty powerful there, right? You can go to mesh control. Maybe you want to go generate the mesh, or let's take a look at the default mesh that ANSYS has out of the box based on the physics I selected, right? I just selected structure. So it's just going to do the basic meshing. We'll see how it is. Maybe I look at it and I go, okay, I'm not satisfied with that. I probably have to refine it here. So this is the power, right? Where to get a higher fidelity solution, you need this kind of control. So that's what it's going to activate it right now. It's in the process of creating it, and it's you'll see a sub process that comes up telling that it is starting to create the mesh, at the bottom here. The nice thing is, while it's doing it, you can even work on your other Creo files. You see, it's a session. You see, you can open up the process manager, and this is telling you that it's in the process of generating that mesh as we speak, right? That's telling you that it is working. The ANSYS, the meshing is working right now. And if I look at my, this is all kind of using CPU, and it's not, leveraging anything GPU at all right now, right? That's what it's doing right now. And once it does it, I'm able to display the mesh, and maybe, you know, there it is, right? It just informed me that I could always open this process manager separately. And sometimes, you know, it'll even give you the steps, right? If you're going to run the analysis, it'll show you the mesh, and it'll show you I'm running it, etc. But it looks like it ran. Now I should be able to display the mesh. And there is a mesh, and I'm looking at the mesh, and it looks like a default mesh. And if I go into my mesh resolution, there it is, right? So maybe you're a very new user, you just leave it right in the middle here, right? It's more like, you know, somewhere it's like a 50% right there. Or do you want to have a higher density, you know, or a coarse mesh or a fine mesh? You have that slider bar you just use. And what happens really when you change those is really changing some of these global mesh size settings, right? By default, they got a couple of options, you know, a few options here, right? Based on curvature or proximity, fixed, etc. So if I go right now, when you were saying the mesh in here, I have you know, two faces, you know, less elements in here, or maybe between one geometry and another geometry, I have lesser elements. I could always go and control that, right? In my global, I could do localized mesh refinement too, or globally, I could say, let's look at proximity and the number of cells that should cross a gap. So when I say gap, I'm talking about this kind of a geometry versus this kind of a geometry. What's going to happen there? Okay, so maybe I might say, okay, I might need 3 of them in here. I could also control the maximum face, the maximum size of the element, maximum face size. You know, they have to be larger. It's about 22 millimeters and 11 millimeters here, which I can again refine it and make it 2 and 1, for example. But those are some options. And then now I just go and regenerate, you know, recreate the mesh, and it's going to essentially work on that process manager right in there. And you might see between that hole and that surface there, you're going to be seeing a lot more, a higher mesh density since I changed it. So like this, you're able to specify if you're more of a seasoned FEA user, you could do this. So that's the nice thing. I like how it has some basic capabilities for new users. At the same time, for somebody that may want a little more fine mesh refinement during the final validation stage, it's helpful, right? And I can just open up this and see at what percent it is and all that, right in here. It looks like the progress is about 10%. At this time, I could just leave it in here, and I could just be working on some of my 2D drawings, or maybe I can keep doing my design work, because it's just a sub-process, right? Your Creo Parametric itself, it could be used for your other day-to-day activities, is what I'm getting at. So just got it done, right? It's still, it's going to just allow, so there's a little display mesh up here. Once it completes it, there it is, right? It's just informing me here. I could either open the process manager, or I can just leave it in there. And if I say, you know, look at the mesh, now, as you can see, that's what I'm talking about, where, you know, so I asked it for 3 elements between this geometry and this geometry. So it is giving me a little more of a higher order mesh. So like this, I have, you know, different controls that you could play with, right? So maybe I want to go with fixed. All I want is an overall, you know, control, right? Where I'm going to control the maximum size, the growth rate for each layer when it creates newer, you know, what should be the size. All that can be controlled. So you got, that's one advantage of using this Creo ANSYS simulation, right? So you have mesh control, and you also have options like, you know, maybe let me open up another example here real quick. You know, we're getting kind of close to Q&A time here, but let's just show a couple of additional examples here. If I open up a 3-part assembly, nothing as big as the last one that I had. And here, all I have is, as you can see, like, you know, a steering joint, and then the U joint, and then a second one, and I have a coordinate system, right? Pretty straightforward assembly. Now, in the case of a component on an assembly like this, I may want to control, like create, you know, the degrees of freedom between this cylindrical surface and the hole, right? Is that going to be a hinge? Is it going to be fixed? You know, how is that going to behave, right? When I apply, for example, a torque and I fix it at one end, this is when you could take advantage of the, let me just go and deactivate everything in here. And let's unhide these as well. and I go into applications, and when I go into ANSYS Simulation, I look at the joints in here, right? When I when I go to refine model, I'm able to add joints, and when I go, I can control the joint behavior. When I go to joint, I select surfaces. I've already selected the surface, for example, from that cylinder to the other cylinder, and I could say what type of behavior I want, right? So these are some of the advanced options that you could potentially use. And I remember in Creo Simulate and some of the tools that I've used, I had to do that with a little bit of additional work like rigid link or weighted link, or sometimes I had to create some multiple spring elements. There's a little bit of additional work that I got to do, and it's nice that that behavior can be captured really quickly there. And you do have, of course, support for surface regions also, right, where you might sometimes want to apply just a localized load somewhere or a constraint. So you're able to split that surface. That's a surface region concept that many of you may be familiar with your Creo Simulate usage. So it's there. Those are, just to give you a high level on Creo ANSYS Simulation. Hopefully that gave you some information there. The other thing that I wanted to quickly touch on before we look at any of the Q&A that you may have is some of you who may not be aware of the Creo Simulation Live product that was introduced 2-3 years ago, and it has been since Creo 4. For that, that's more like I don't want to create the mesh, and I don't want to spend all that time. I just want to have some quick upfront, feedback or direction as to if I'm going in the right direction or not. And maybe I take the role of an engineer or designer that may be working on this support component in here on this assembly, and I'm in my regular Creo mode. I activated the part, and I may just say that, okay, I might want to extrude this shape. For example, I may want to just go extrude this all the way till the surface. Maybe I want to go to side 2, and I just, I'm holding down shift, and I'm going to shift selected up to surface right there. Now, I may have other sketches that I'm thinking still, right? I'm still in my concepting phase. At this point of time, I cannot afford to send it to somebody and do the typical FEA that you do at a final validation stage. I want some quick feedback. So for that, we recommend kind of using, so if I go to my part and maybe open this in a separate window, for designs like these, and it can also work on assemblies, by the way, but I'm not going to be using, I might just go during my initial state, I just go into live simulation. So I didn't go to applications, Creo Simulate or Creo ANSYS Simulation. I went into live simulation here, still loading the Creo Simulation Live. So this is using the ANSYS Discovery Live product that, that is what is powering, what is working inside. That's the engine. So here it looks very similar, right, to what I showed you, except that this is going to just use the GPU and give me immediate feedback, right? There's no run button. If you see here, I have loads constrained, but there's nothing called run, solve. There's no, meshing, nothing like that, right? All you're doing is, okay, I'm going to fix it here, and I want to see if it will withstand a 100-pound load right in here, right? That's really what I want. Pretty straightforward in here. So I want to go and say maybe give it in the y-axis, maybe about so much pounds in here, and I have, of course, my Creo material, right, steel, that takes over, right, and I simply hit this little show me the results, and when I hit that, this is when it's using my graphics cards GPU that I was talking about, some of the requirements for Creo Simulation Live, where it's instant feedback, right? It's pretty much, I mean, this is a live demo, right? I'm not, this is not a video or anything. It just gave me immediately, it's telling me that in my 1 Misi stress, let's see here, is about 15 megapascals in there, right? That is what it's telling me. I can go back to my design mode, right? I could be in a regular Creo modeling environment. I'm not even in another application or anything like that, right? And I could say, let's go redefine this and say, instead of this, I may be using this guy instead. I middle click, and as soon as I change it, I didn't even have to hit, regenerate or go to applications and then rerun or show. It knew to go back to the blue color, and that's the power of the GPU-based computing, right? It's using that ANSYS proprietary voxel-based meshing, or that we don't even get to see the mesh or anything, right? It's just, we do have a slider where we can control how much amount of the GPU it's using, but it's pretty quick, and now it's increased. So I don't like this. Maybe we shouldn't use this type of a design as moving forward, right? Let's try this one and see what happens. I have multiple sketches, as you can see here, right? I just had multiple external sketches in here, and I'm just referencing each one of them, just a simple design thing that you're all doing in Creo. But it's nice to see that immediate feedback as I'm in my ideation or design exploration stage. It gives me right there, it's 17 megapascal, so that's a lot better. Now I'm going to go back and say, maybe let's switch back to maybe the surfacing guy in my company, right? The surfacing, you know, they like these industrial guy. He's probably recommending to create this a cool surface looking geometry, and let's see what happens when I use that. So I'm really using these different options to just see before doing a final check if I'm going the right direction there, right? So yeah, for the there's a question. I just see a question. Maybe I should answer that right now. How does accuracy compare CSL to simulate to Creo ANSYS? A great question, Lee. So that is so I'd say, you know, we have some comparison studies and everything, and it's within 10% is what I would say on models like these, where I have the time is the key here, right? You know, you maybe on a large assembly in Creo Simulate, maybe you're running it for 3 hours, the multiple pass adaptive analysis. But when you do that same thing, assuming it's all bonded and no contact and things like that we don't support inside of Creo Simulation Live, you may be able to get that in 5, 6, or 10 seconds. It's more the time is the key here, where you're able to get quick feedback. And as for the accuracy itself in here, instead of Creo or instead of Creo Live Simulation, you have a little setting like if I go to my study and performance options in here, I am able to go control the speed versus accuracy. So obviously if I'm just doing a demo in here and I've left it at the default in here like 20, 30% or so, I could always slide it all the way to the right. So it's kind of using the GPU, the RAM, the video RAM that I was talking about, so it can use entirely, right, the 4 gig or 8 gig RAM, the VRAM that I have on my GPU. I could, and with that said, I'm just saying it's going to be within 10%, and obviously it has its limitations, right? It's going to assume everything is bonded and you don't have contact, things like that. Now I may go and redefine and say, let's go back to this one, and I may say, okay, I think we probably like the initial stage where we were in, right? So that's the best, like whatever, like 15 or 17 megapascals we got. Let's start from there and let's try to improve this, right? I may just go in here and say, okay, so maybe I'm looking at my max minimum and it shows the maximum somewhere here. So maybe I just go into my edge and say, let's create a round in there. As soon as I'm showing my intent to do some design work, the analysis results are hidden automatically for you. I middle click out of it, or I'm done with it. Again, the analysis kicks in. This is really nice where, you know, I've been doing FEA since '96 when I started using Mechanica and sort of the, other ANSYS products. And this quick feedback is what I like about this Creo Simulation Live, right? Where I didn't have to go back and rerun the analysis or update or do anything in here. It's the GPU thing is pretty exciting, I think. Of course, it has its limitations when you get into higher fidelity solutions, and that's why, you know, I'm saying we have different options in here. Now I was able to bring it down to 13 megapascals right in there, and now maybe I'm going to just say, okay, let's go add a little chamfer in here, right? I'm going to add some. Let's see here. We'll just use a D1 by D2 type chamfer. Make it add some material in there. That should kind of help a little bit on that corner as well. And so the nice thing is it's almost like there's somebody's there, you know, the analyst is there right there with you as you're doing the design. That's something that I like, especially for those who may not be experienced. For new designers, right? I know we do sometimes calculations, and I still do that sometimes, you know, that's something we trust, but this gives you some immediate quick guidance, and there are some validation documents too. I'll show you in the help file that wherein they have compared, you know, going back to one of your questions on how do they compare. I do have some comparison documents with PTC. Instead of PTC's help, also they have some validation documents that you can go over and test out yourself. But there it is, right? It's now at this point I'm thinking maybe I should be adding. I'm going back to my model environment mode. I should be able to add like a rib in here. Maybe we'll just add a quick rib and see. That should help, obviously. So we all know that from experience. So that should help relieve the stress a bit. So I'm going to go just say go from here to here, right? And then let's go add that in there. Oh, a rib, as you know, requires an open sketch and like an extrude. There it is, very powerful. It can accommodate any geometry. I just got through that. As soon as I'm done creating that feature, there it is, right? It's like in your graphics toolbar, you have something that's always on. You can always turn it off, but I just left it on so you can see it in real time, what's happening in there, right? And that didn't really help a lot. It actually increased from 13 to 15, it looks like, because I didn't create the rounds and everything. But I should be able to go and say, let's go pattern this guy, maybe from, let's see if I could use that direction pattern. We'll just go with this surface, and I want to go do a direction pattern and do like, let's see here, about 3 of them. I'm done with that. And what this does is it's again, it's taking a little more time with more geometry, as you can see, but it's still pretty quick, right? Maybe 3 seconds maybe, and it's coming down to less than 10 megapascals there. I could further, improve it by just editing it. Maybe do like a, maybe I'm sure if you add more material, it should help too, right? Maybe making it less flexible there at the top, when you apply a load in there. So these are the things that if you, without Creo Simulation Live, or I'm just thinking the normal workflow that you may be using, where you go to your applications, that particular specific simulate tool, you do your meshing, you do your, it's more like the final validation is involved, right? Even though it may be fast in most solutions these days, but this one is that real-time feedback is what I like in here. And maybe, and this is, I'm good with this, right? We have a good factor of safety, depending on the yield strength of the material. If it's for steel, this is really good. For 230 megapascal, this is really good. But from 15, we were able to bring down to, from 15, 20, we brought it down to 6. And now I'm thinking, okay, I probably should go back to my assembly in here, and I could pretty much do an entire assembly with that, right? Now that I know this is going to work, I can just go and mirror this guy over to the other side, right? Maybe let's see if I could use one of the planes in here. Let's do a little preview just to make sure it's mirroring right in there, right? So that's good. And once that's mirrored, now maybe I might want to know, look at the entire assembly. Now, there's also a way to look at just one part while in assembly, right? I could go into an assembly, and when I do live simulation, it's pretty nice that I can go and import studies. Remember, I was talking about how you can import studies right in here. I can import an existing simulation from a part to an assembly level. And I'm able to go select that part in here, right? And I go structure, right? That's the one that we ran. I just ran it in the part level. And you see how it got activated in this level right in here, right? I can just go, let me go activate that actually. There's the fixed constraint and everything that we did. The only thing now is I have to ensure that the scoping, there's something that in Creo 6, they introduced the scope option in Creo Simulation Live that I really like, where I'm able to scope specific components where it should run the simulation, right? I'm just scoping it for that. So I have the scope option. And now if I go show me the results, right? Remember, I told you there was no run button here. Just show me the results. It is not doing on the entire assembly. It's just in the context, I have the assembly. It's almost like activate the part and show me the results only in that part, right? That's really what it's going to do right now. And I can always do it in the entire assembly too. I'll just do that in a second here. I know we're running a little bit over time, so just wrap up with this last few minutes here. If you have any questions, feel free to start typing in there, but there it is, right? So I have this part, and I'm looking at it, and I look at the animation, all that, but now that I've done this, I probably want to create a newer study here. I want to activate another study, right? A new study in here, but it tells me that you're not able to view any results because you don't have constraints and loads, right? So it's checking it for you. So I'm going to go say, let's go set this guy as our fixed constraint. And maybe all the parts, we have materials assigned, and maybe I want to go assign a specific load or a force to, let's see if I could go to directions, and I'm going to just use, we'll just go use a specific value here. And then I'm just using my triad in here. There it is, right? And now I have the entire assembly in there. I didn't set up any type of scope for this. So if I don't set up a scope, that means every single geometry is going to be used, right? I didn't have to go and defeature it. And then normally when you do the mesh itself, you have to get rid of unwanted rounds, and there's so much things that you do, right? Whether you use a higher end solution like Ansys, Nastran, Hypermesh, or even our own Creo Simulate, there's always that initial pre-processing time that we all spend, as many of you who have done FEA know about, right? I'm not doing that in here. That's the key, right? Even on a quite a medium complex assembly like this, I was able to run it and get some feedback. But again, the assumption here, the huge assumption here is the entire assembly is bonded or welded, right? In the real world, that may not be the case, right? You may have a fastener that goes in here with a preload, and there has to be contact, and that's when those higher fidelity options will help. But it's good to get a rough overview of what happens if they're all bonded. And now if I'm applying a load, what happens in here? That quick instant feedback is the key here, right? That's really the key. So, okay, so let me turn that off. Let me see if there's any other questions in the questions area in here before I get back to let's see here. There it goes. So we have been doing quite a few of these webinars over the last few months, whether it's Creo 7 What's New or Creo Simulation Live. I did one on Creo Simulation Live. This was mainly on Creo ANSYS Simulation, but since some of you had some questions related to that, I thought of showing a little bit on the live as well. But if you go to visit TriStar.com, there's a resources area where you can look at our webinar replays, or you can go to TriStar's YouTube channel, and there also we have all these webinar recordings, right? It could be on Windchill, MathCAD, Creo, right, and all the various PTC products out there. So let me just give a minute here if anybody has any other questions. Let me see. Yeah, regarding the comparison, if you go to your, maybe I'll just quickly point that out. If you open up PTC's help and the comparisons and validations, right? If you go to your simulation, whether it's going to be your old Creo Simulate that has verification guides, as you can see here, I can go to verification guide, and they have results compared with ANSYS, Nastran, NAFEMS, or Theory. They have some, as you can see, some example files that you can try it out yourself. That is on Creo Simulate. Same thing, if you go into Creo Live Simulation or ANSYS Simulation, right? So you got some verification guides in there also, right? Solver settings. If I go into right in here, verification models, there's your verification guide. They even say what kind of graphics card they used. You can even download some of the files. And there was your verification guide as, maybe if a problem like this, what happens with ANSYS Discovery Live, how much we got, with Creo Simulate, how much we got, with Creo Simulation Live, how much we got, right? So the 10% error that I was talking about, right, that's within 10%, and maybe the speed is a key again here, right? So there are a few verification guides that you can review. I know that is one of the questions that came up, so. All right, so I think there are no other questions here. Feel free to reach out to us with any questions you may have, or visit us at tristar.com or contact us at 800-800-1714. Okay, thank you again for spending the time. I hope it was informative. We look forward to seeing you soon in another webinar. Until then, have a great rest of the week. Thanks.